Welcome back to the Scotti-BYTE channel, and this is Scott. So today I want to talk about networks on Docker versus on LXD. So Docker and LXD containers both default to an internal IP address on a private NAT network. A lot of people aren't aware of that, but if you think about it, when you create a Docker application and you go ahead and run it, you're always in this position where you're going to expose certain ports, and not for outbound communication, but for inbound communication. So Docker and LXD freely communicate outbound or out to external networks. Inbound communication on Docker is restricted to what they refer to as exposed IP port numbers. An inbound communication on LXD is normally not permitted, but there are several ways to achieve it. So there are ways to expose LXD ports through the LXD host, but I prefer to use bridging and MAC VLAN to expose LXD containers with their own addresses on the LAN, and I've shown that several times before on the channel. So here's a simple conceptual view of how a home network usually appears. So at the top here, we've got our router, and its gateway address on the local network is 192.168.1.1. On the left-hand side, we have a Docker host, and on the right side, we have a LXD host. And it really doesn't matter what kinds of machines these are. These could be bare metal, they could be virtual machines, or they could even be LXD hosts. So in this particular example, we're going to say that this Docker host has the address of 192.168.1.50, which would be on this network of 192.168.1.0 with a subnet mask of 24. So inside of this particular host that's running at the 50 address, we have 5 Docker hosts. So they're running 5 different Docker applications, and they're running on an internal Docker network, which is a private NAT. That is the way that Docker creates containers by default. So in this example, we have 172.17.0.5.6.7.8 and .9. And down here, we've got an example of where we are showing a Docker compose file to run the application called Tautuli, which is a data reporter for the Plex server. And here you can see that it's exposing, or it uses port 8181 internally, and it's exposing port 8181 on the host. So port 8181 would be accessible from the outside into that particular Docker container. So that means if there's another application running on .6, it could not also expose 8181. It would have to pick a different port number, and so on down the line. Well, we've all learned that that's the way you do things on Docker, and it's not particularly a problem. It's just kind of the de facto standard. The thing is not every application has one port that it shares. A lot of applications have 4, 5, or 6 different ports that they may want to provide back through the host and through the network for external access. And then you have that going on with every single Docker host out here, or single Docker container you might be running inside of your Docker host. So in reality, this can become actually pretty complex. So over here on the right side of the diagram, we have a depiction of a LXD host. And again, this could be bare metal or it could be a virtual machine, but it's running at 192.168.1.60. And you can see that there's a whole mess of containers in here, and they too are operating on a LXD private NAT network, and it actually uses the LXD bridge that you notice on your machines running LXD called LXD BR0. So that provides inbound or outbound access, but it doesn't provide inbound access. And you can see that these are private addresses that do not relate to the 192.168.1 network at all. And then just for illustration purposes, I also said that there could be a Docker container in here, but I crossed it out. And the reason for that is because, and I've indicated here in this note, that Docker service on a LXD host at the host level causes traffic to LXD containers to fail. And so the problem is that when you install Docker, part of the rules that it defines ends up dropping unmatched forwarded traffic, and it does so by modifying the IP tables. So I'm going to show you a better way to do this, because I know a lot of people might want a host where you run LXD containers and run Docker containers at the same time. So then we move on to what I call my recommended configuration for LXD and Docker. Again, we've got our router with the same network and the same address of 192.168.1.1 on our 192.168.1.0 network. And this time we've got our host, which we're going to call a LXD host, and it's running at 192.168.1.50. But what we've done is we've taken his host controller, and let's just say that his host controller is a device called EMP3S0. I mean, yours may differ. You can do an IPA or an ifconfig to figure out what your physical address is of your device. But here I'm building a netplan file, and I've covered this on the channel before, but in this particular case, I'm building a netplan file. I'm telling it that DHCP is set to false for both IPv4 and IPv6, and then I'm building a bridges section, and I'm creating one bridge, and I'm calling it bridge 0. And again, we reference the same physical device that is our Ethernet device for our host. In this case, EMP3S0, yours may differ. And then I'm putting a static address in here of 192.168.1.50. And the reason for that is because I like all manageable devices on the network to have static addresses so we can find them. Makes sense. And then we have this routes to section where it says routes to default. And it's basically saying that the default route is 192.168.1.1, which is the router, and that's correct, so it can get to other networks and out on the internet. And then we have a name server section, and I say, well, use the name servers for Cloudflare primary and secondary. You can, of course, use your own name servers. And then under the parameters section, the only thing of real interest here is where I've set spanning tree protocol equal to true. And the reason I've done that is because if I do anything funny inside my LXD host, I don't want to end up creating a router loop, and this avoids that problem. And so the next step here that we've got is we're going to create what's called a LXD bridge, and we're going to use this command LXC profile create, and I'm going to call it bridge profile very creatively. And then I say LXC profile device add to bridge profile ETH0. Why ETH0? Because inside of LXD containers, their Ethernet device is always called ETH0 if it's the first device. And then NIC type equals bridged, and the parent is going to be bridge 0. That's the bridge that we just created here inside the netplan file, assuming we've put that netplan file in place and done a netplan apply, as I've done on the channel before in my examples. So now we have a bridge device, and now we have the ability to create containers on the bridge, which is really great. So again, I have my disclaimer down here that don't put Docker out at the LXD level because it messes with the networking. But here's our solution. Here's how we get around this problem. So inside of my LXD host now, I actually have 3 LXD containers, and all 3 of them are bridged. And now you can see they don't have NAT addresses any longer. They actually have addresses out on the LAN of 192.168.1.100, 1.101, and 1.102. And the reason they're able to do that is because when I create the containers, for example, for the example of, say, the first one, really the example of all of them, I said, LXC launch Ubuntu :2204. I'm going to call this thing Tatuli. So I'm calling the LXD container Tatuli. And then I'm going to say use the bridge profile. That's what gets at this address out on the LAN. and then I say boot.autostart equals true. That just means when this LXD host boots, it starts that container all the time. And then also very important, security.nesting equal to true. And what that does is that allows us to be able to run Docker apps inside of a LXD container. So then it really doesn't matter, because I have a 100 address, a 101 address, and a 102 address on my 3 LXD containers running down here. So they look like 3 different hosts presented out on my LAN here, but they're really inside of this LXD host. And then I can create Docker instances inside of them, and they're going to go ahead and choose their typical Docker internal NAT addresses. But we really don't care, and we don't even care if they end up being the same. In this case, I showed that they were the same. It doesn't matter if they're the same or they're different. You're not going to have any conflicts. And the reason for that is because this Docker network running on this LXD host has nothing to do with this Docker network running on this LXD host, which has nothing to do with the Docker network on this LXD host. So now that we've created the container, and we create the other 2 containers in a similar way, obviously just give them different names, and they'll have different addresses as well. And by the way, once they get created out there, you're going to want to go out to your router and set DHCP address reservations for all these LXD containers, in this case, these 3, so they have static addresses, because the thought is that you're going to be hosting services you want to get to, and you don't want those addresses changing. So here, as an example, I have that Docker Compose that we looked at in the previous slide, and now instead of offering it on port 8181, which is what the programmer did inside of the Tatuli container for the Docker app, I can offer it on port 80 at the LXD host. And the reason for that is because they'll just access port 190 or address 192.168.1.100 at port 80, and they'll get to the Tatuli app. In this case, I have a Docker run command. It does the same kind of thing, except this time I'm launching Whiteboard app, and it uses port 8080 internally, but I said, hey, let's use port 80 out here. And so they're going to connect to, the users that is, will connect to port or IP address 192.168.1.101, but they'll connect to port 80. And so this port 80 won't conflict with this one because they're running at different addresses, and so on down the line. So this has an advantage to being able to build applications that are actually discrete from one another, and Docker apps, 1 per LXD container. So in summary, LXD containers are resource cheap. And consider nesting your Docker containers inside of LXD containers that are in turn bridged to your LAN to simplify Docker container port forwarding, and that's what we just did in my example on the second slide. And then Docker nested in LXD containers work very well and provide a dedicated Docker resource for your Docker apps. If each Docker app runs in a dedicated LXD container, you're never going to have to worry about IP port forwarding conflicts. So anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.